Vapor pressure depends on several factors like temperature and nature of liquid. Copy it first. All of us know what is vapor pressure now. We have done that in the last class. Pressure exerted by the vapors of the liquid on the surface of liquid under the condition of equilibrium between condensation and evaporation.
Excuse me, sir.
Yes.
Sir, could you invert the screen?
Again, what?
So it's not visible. So like, could you get
Screen is not visible.
So no, like it's a bit blurred. So like, could you fix it a bit?
Is it clear now?
So the screen was clear. Could you slide it, do it, put it the other side, like rectangular?
You want me to slide it, right?
Yes, sir.
The screen has gone black. Now it's not visible only. It's visible now, Rishikesh.
Yes, sir.
Any problem to anyone this in this now? Related to screen. Right
So
on.
just
Yes. What happened?
just scroll up.
Okay. Till this whole diagram we have done in the last class only. You must have read about it.
Okay, sir. Thank you, sir.
Vapor pressure is directly proportional to temperature. Vapor pressure is directly proportional to temperature. Second, vapor pressure. Yes,
We are done, sir.
vapor pressure of a liquid is inversely proportional to the intermolecular forces present in it. Okay. All of you written both the factors. All of you got the notification for the class? Did all of you get the notification of the class?
Yes, sir.
Yes, sir.
Any problem to anyone in these two factors? Okay, so if we have water and we have acetone, which will have more vapor pressure?
Water.
Why?
Due to more intermolecular force.
Do we want more intermolecular force or do we want less intermolecular force?
Ah, yeah, sorry, sir. Acetone.
Water has hydrogen bonding. This has van der Waals force. So acetone has weaker force of attraction. Hence more vapor pressure. Okay. Understood this question? Among water and ethanol, which has more vapor pressure? Water and ethanol, which has more vapor pressure? Water. कैसे मधुरा?
So please scroll up.
Madhura, water also have covalent bond, but covalent bond is an interatomic force. We are talking about intermolecular force. एटम और एटम के बीच में जो फोर्स है उसके बारे में बात नहीं हो रही है. मॉलिक्यूल्स के बीच में जो फोर्स है उसके बारे में बात हो रही है. ठीक है, ये वाला बॉन्ड कोवेलेंट बॉन्ड है. दिस बॉन्ड इज आल्सो अ कोवेलेंट बॉन्ड. Both of them have covalent bond. That is only we have a molecule. But we are not talking about that force. We are talking about the force of attraction between the molecules. Force of attraction between the molecules. ये जो मॉलिक्यूल मॉलिक्यूल के बीच में होता है. You tell me which will have more hydrogen bonding. ज्यादा हाइड्रोजन बॉन्डिंग किसमें होगी? अल्कोहल और वाटर. Which will have more hydrogen bonding? See, this can have hydrogen bonding like this. हाइड्रोजन कर सकता है. This hydrogen can also have hydrogen bonding. And this oxygen can also have hydrogen bonding. But in this case, alkyl group cannot have hydrogen bond. Because hydrogen bonding is the force of attraction present between hydrogen and phone. Water has more hydrogen bonding. Water has extensive hydrogen bonding, and hence alcohol will have more vapor pressure. Done, all of you? Understood, Sanika? So we can say that volatile liquids have definitely. I was coming to that only. I will take this word volatile after talking about boiling points. Very good, Tanmay. Understood. All of you understood this? Any problem to anyone? Okay. Now, what do we mean by boiling point? Boiling point का मतलब boiling point का मतलब anyone know what is boiling point? The temperature at which vapor pressure of liquid is become equal to temperature at which vapor pressure of liquid become equal to atmospheric pressure. So the temperature at which vapor pressure become equals to atmospheric pressure is called boiling point. Okay, understood boiling point? Understood boiling point? Now, what do we mean by that? We know to boil a liquid, we have to heat it. To boil a liquid, we have to heat it. To boil a liquid, we have to heat it. That means we are increasing the temperature to boil a liquid. We generally heat the liquid to achieve boiling point. That means atmospheric pressure should be bigger than vapor pressure, because हम temperature increase करके vapor pressure increase कर रहे हैं, so that it becomes equal to atmospheric pressure. Let this be the atmospheric pressure and let this be the vapor pressure. We are heating our liquid. We are heating our liquid so that temperature increases. When temperature increase, vapor pressure will also increase. And at some point, it will definitely become equal to the atmospheric pressure. That particular temperature is called boiling point. Any doubt in this? Any doubt in this? Any problem to anyone in this? आप टेम्परेचर इंक्रीज कर रहे हो जिससे वेपर प्रेशर इंक्रीज हो. Why you want to increase vapor pressure? You want to make it equal to the atmospheric pressure. At some temperature, it will become equal to the atmospheric pressure. That temperature will be called the boiling point. All of you understood this? Akarsh, Aradhya, Chaitra, Diya, Faye, Janil. Any problem to anyone? Madhura, Natasha, Sanika, Sanjana. All of you understood this? So tell me, all of you have copied this also? If this is the atmospheric pressure, you have two liquids, A and B. Which liquid will have more boiling point? Which liquid will have more boiling point? Which liquid will have more boiling point? किस liquid को ज़्यादा heat करना पड़ेगा? Which liquid will have more boiling point? Which liquid is to be heated more so that at some temperature it become equal to atmospheric pressure? Definitely B. Definitely B. इसको ज़्यादा heat करना पड़ेगा, इसको कम heat करना पड़ेगा. So can we say vapor pressure is inversely proportional to boiling point? Can we say vapor pressure is inversely proportional to boiling point? So, vapor pressure is inversely proportional to boiling point. Okay. How will you relate intermolecular forces with boiling point? Intermolecular forces कैसे relate करोगे boiling point के साथ?
Directly proportional.
Directly proportional. Intermolecular forces are inversely proportional to vapor pressure. Vapor pressure is inversely proportional to boiling point. Hence, intermolecular forces are directly proportional to boiling point. Understood. All of you understood? It should be very much clear that increasing surface area will have no effect on vapor pressure. Increasing surface area will have no effect on vapor pressure. It should be very much clear that increasing surface area will have no effect on vapor pressure. You do not have to think like evaporation पे depend करता है, evaporation surface area पे depend करता है. If surface area increases, evaporation increases. If evaporation increases, vapor pressure increases. You do not have to think like that. It will depend only on temperature and nature of liquid. Okay. So, because you may achieve equilibrium earlier, you may achieve equilibrium later, but the vapor pressure will always be count at the time of equilibrium. So, whether it is coming late in the smaller surface area or it is coming earlier in the larger surface area, it won't matter. All of you understood till here?
So could you please scroll up? Thank you, sir.
Done?
So just scroll up, I got disconnected. Done, sir.
Among water and ethanol, boiling point water will have more boiling point. among acetone and ethanol. Boiling point among acetone and ethanol. Boiling point ethanol hydrogen bonding. If we consider pentane a liquid, because alkanes with higher molecular masses are actually the liquids. This is pentane. This also have 5 carbon. मैक्सिमम इंटरमॉलिक्यूलर फोर्सेस किसके पास है? मैक्सिमम इंटरमॉलिक्यूलर फोर्सेस
Sir, C.
A will have maximum intermolecular forces. More the surface area, more the van der Waals force. More branching, less intermolecular force or van der Waals force. Okay. Any doubt in this?
So please scroll up. Okay, so thank you.
Volatile.
So one
Please
second,
and
please scroll up.
again what?
Sir, scroll up.
This much? Done. Sam done. Liquids having low boiling point are volatile liquids, liquids having high boiling point are non-volatile liquids. My voice is not clear. Hello. Am I audible properly now? General.
Yes, sir. Now it's clear.
All of you have written till here. Liquids have low boiling point are volatile liquids. Liquids have high boiling point are non-volatile liquids. So now we can relate with vapor pressure. Volatile liquids or high volatile liquids are inversely proportional to, so directly proportional to vapor pressure. More the vapor pressure, more the tendency to become volatile liquids. Understood? Volatile liquids are also called low boiling liquid. Low boiling liquids. Understood? Done, all of you? So question can come on this volatile liquids also. Which of the following is maximum volatile? Which of the following is minimum volatile? Any problem to anyone? Normal boiling point and standard boiling point. Normal boiling point and standard boiling point. What is normal boiling point? Where pressure is taken as 1 atmosphere. Atmospheric pressure is taken as 1 atmosphere. Atmospheric pressure is taken as 1 atmosphere. Standard boiling point. Standard boiling point. Atmospheric pressure is taken as 1 bar. Okay. If I say that 1 atmosphere is bigger than 1 bar, then which boiling point will be more? वन एटमोसफेयर जो है 1.013 बार के बराबर होता है। विच बॉइलिंग पॉइंट विल बी मोर, नॉर्मल बॉइलिंग पॉइंट और स्टैंडर्ड बॉइलिंग पॉइंट?
Normal, sir.
विच बॉइलिंग पॉइंट? नॉर्मल। तो नॉर्मल बॉइलिंग पॉइंट जो है वो होता है 100 डिग्री सेंटीग्रेड और स्टैंडर्ड बॉइलिंग पॉइंट इज 99.6 डिग्री सेंटीग्रेड। किसका? वाटर का। Understood? All of you? Write down. Boiling is a bulk phenomenon. Evaporation is surface phenomenon. Okay, this also we should know. Understood whole about vapor pressure and boiling point? Any doubt to anyone? Any doubt to anyone? I don't. Sir,
So please roll up the tape.
surface.
Yes, sir. Thank you.
What is surface tension? सरफेस टेंशन क्या होगा?
So scroll up.
You must have read about surface tension. What is surface tension? Force per unit length on what? सरफेस पूछ रहा हूं, आप मुझे फॉर्मूला बता रहे हो यार सर।
Done, sir.
श्रिंकिंग प्रॉपर्टी। चलो कुछ तो अलग है। श्रिंकिंग प्रॉपर्टी। एनीवन एल्स? व्हाई यू थॉट श्रिंकिंग, सनिका?
So for shrinking into minimum surface area, I mean in the
Again,
case of
what?
liquids.
Means the particles which are present at the surface, they are feeling some shrinking according to you, right? Right, Sanika? Now the surface particles are feeling some shrinking. We will say it is a force. Surface particles are feeling some force. Force को हम टेंशन बोलते हैं. So surface particles are feeling some tension inside due to the intermolecular forces. Surface particles are moving some tension, feeling some tension, some force from inside from the other molecules, and that tension is called surface tension. That force is called surface tension. Okay, Sakshi. For example, we have particles like this, and we have particles like this also. So the particles which are present in the bulk, they are feeling force of attraction from all the sides. The particles which are present in the bulk, they are feeling the force of attraction from all the sides. The particles which are present in the bulk, the particles which are present in the bulk are feeling force of attraction from all the sides. The particles which are present in the bulk are feeling force of attraction from all the sides. Right? Particle B present in the bulk feeling or facing intermolecular forces from all sides. Net force is zero. Right? Any doubt in this? Article A present on surface is feeling intermolecular force from inside only. So it has net inward force. So it has net inward force. So it has net inward force that is called
So please scroll up.
just surface tension. डेफिनेटली साक्षी डेफिनेशन वही होगा जो आपने बताया. आई एम जस्ट एक्सप्लेनिंग व्हाट डज दैट मीन.
Sir, can
At
you read the
last it is,
whole sentence? Whole sentence.
I said particle B present in the bulk is feeling intermolecular forces from all sides, so net force is zero. Particle A present on the surface is feeling intermolecular force only from inside, so it has net inward force called surface tension. Okay.
Thank you, sir.
Any problem to anyone in this? Any doubt in this? Definition: force acting per unit length perpendicular to the line joining to the line drawn on the surface of liquid. ठीक है? If we draw a line on the surface of the liquid, उसके perpendicular जो force लग रहा है, the force is acting perpendicular to it and downward, perpendicular and downward per unit length, उसको बोलते हैं surface tension. Any doubt to anyone? Any doubt to anyone in surface tension? Am I audible?
Yes, sir.
So just scroll up.
Done.
So you scroll up.
Yeah, it's not visible.
So now it so done.
Oh. It is denoted by gamma. ऐसा यूनिट क्या हो जाएगी इसकी? गामा की ऐसा यूनिट क्या होनी चाहिए? संजना पद्म मधुरा शिफा. What should be the SI unit? SI unit. आप मुझे डायमेंशंस बता रहे हो साक्षी. Force per unit length. Force per unit length. Force per unit length. Okay, साक्षी. CGS यूनिट क्या होनी चाहिए? CGS unit. Will be dyne per centimeter. Dyne per centimeter. Dyne per centimeter. इसको capital D. Dyne per centimeter. How this dyne per centimeter and Newton per meter related? How this dyne per centimeter and Newton per meter related? How are they related? एक न्यूटन पर मीटर में कितना डाइन पर सेंटीमीटर होगा? That's what I'm asking.
10�7.
10�7 कैसे? 1 Newton is equals to 10 to the raised power 5 dyne. This is correct? Is this correct? 1 meter is equals to 10 to the raised power 2 centimeter. This is correct? So 1 Newton per meter पे हम लिख सकते हैं 10 to the raised power 5 dyne upon 10 to the raised power 2 centimeter. मतलब 10 to the raised power 3 dyne per centimeter. Right? The one who said -7 understood? All of you understood? Very good, Sakshi. Dimensions you must be knowing very well. आप जो solve कर लोगे, so it will be kg per centimeter square. This will be dimension. Okay, but as Sanika said that it is a shrinking property. All of you done this much? All of you done this much? Okay. Now, as she said that it is a shrinking property, we will write effect of surface tension is to reduce the surface of liquid to minimum. Is to reduce the surface of liquid to minimum. Reduce the surface of the liquid to minimum. Okay. Now, if we try, for example, you had some liquid, and on that some surface tension was acting. Now, because of surface tension, this layer has come down. This layer has come down. Liquid had shrunk. This layer has come down. Now, you want to make this thing opposite. You want to take it back. For that, you have to do some work. For that, you have to do some work. Are you getting it? Because of surface tension, surface particles have come some down. Shrinking of liquid has taken place. Now you want to go back. You want to go achieve the initial position. For that, you have to do some work. आपको कुछ work करना पड़ेगा. Getting it? To increase the surface area of liquid, we need to pull the molecules against the intermolecular forces, right? Any doubt in this statement? Any doubt in this statement? Any doubt in this statement? No. I'm लिखेंगे surface energy. Surface energy. Surface energy. Energy required. Energy required to increase the surface area of the liquid by 1 unit is called surface energy of liquid. Please mute your mic. Aditi, please mute your mic. ये है force per unit length. Surface area will be joule per meter. Understood? Sorry, surface energy will be joule per meter. Any doubt in this? On what factor will it depend? On what factor will it depend? किसकी वजह से हो रहा है surface tension? What is the root cause? Very good, Yash. And how we can tackle with it? How we can tackle with it, Yash?
So please scroll up a bit.
Yes, how can we tackle with it? क्या
Yes,
किया
thank
जाए
you.
कि इंटरमॉलिक्यूलर फोर्सेस का इफेक्ट खत्म हो जाए? वेरी गुड ऋषिकेश, वेरी गुड. दो फैक्टर कौन से हो गए? एक तो यश ने बताया इंटरमॉलिक्यूलर फोर्सेस, that is again nature of liquid. दूसरा ऋषिकेश बोल रहा है कि टेम्परेचर से इट कैन चेंज. अंडरस्टूड. How it will relate with intermolecular forces? Yash, you said it will be intermolecular forces will be the factor. How it will relate with intermolecular forces? कैसे relate करेगा? How will it relate with intermolecular forces? Directly proportional. So surface tension is directly proportional to intermolecular forces. Same questions that we have done before.
Sir,
And
please
how it
scroll
will
up.
relate with temperature, Sanika? How it will relate with temperature, Sanika, Sanjana, Rishikesh? Inversely proportional. And why is it so, Sakshi? What will happen on increasing the temperature, Sakshi? Intermolecular forces weak हो जाती है on increasing the temperature. Very. Sakshi, reverse is true. Understood. Sanjana, it's high. When temperature is high, intermolecular force will decrease. You will be able to break the bonds. Understood, all of you? Anyone know what is glycol? Glycol पता है किसी को क्या होता है? Anyone know what is glycol? Glycol. Ethanol. Glycol. Glycerol. Which will have maximum surface tension? Maximum surface tension. Maximum surface tension किसके अंदर आएगा? क्यों यश? Which has maximum hydrogen bonding? मैक्सिमम हाइड्रोजन बॉन्डिंग किसके अंदर है? जिसमें सबसे ज्यादा OH ग्रुप, हाइड्रोजन बॉन्डिंग, हाइड्रोजन बॉन्डिंग, हाइड्रोजन बॉन्डिंग, हाइड्रोजन बॉन्डिंग। तो glycerol is better than glycol is better than ethanol. Done. Done, all of you. Right, and viscosity. Anyone know what is viscosity? Viscosity. Anyone know what is viscosity? Very good. Liquids are known for their fluidity. Liquids are known for their fluidity. So if something is resisting to it, that becomes a readable thing. So resistance to the flow of liquid called viscosity. Resistance to the flow of liquid called viscosity. Resistance to the flow of liquid is called viscosity. Okay. And this resistance will be because of viscous behavior of liquid is because of intermolecular forces. Viscous behavior of liquid is because of intermolecular forces. More the intermolecular force, more is the viscosity. Okay. If you consider two layers of liquid,
Can you scroll up a bit? Yes, sir. Thank you.
if you consider two layers of liquid, this is touching floor, floor you can say the resisting surface, the viscous surface. Okay, so which layer will have more speed, A or B? Which layer will have more velocity, A or B?
Excuse me, sir.
Yes, yes.
Can you just scroll up, please?
Done, Sania.
Yes, sir. Thank you.
If A is the area of layer and dz is the distance between layers. So viscous force will depend upon A and dz. How? कैसे viscous force depend करेगी? Distance between the layer पे और surface area of the layer पे. How viscous force will depend upon the distance between the layer and surface area of the layer. I should say more the surface area, more will the friction. More the surface area, more will be the friction. So more is the viscosity and inversely proportional to the distance between the two layers. Understood? dv is the velocity difference. Velocity difference between two layers. So this how viscosity is related. Viscosity is directly proportional to the surface area of the layers, inversely proportional to the distance between the two layers, directly proportional to the change in velocity between the two layers. Understood?
Sir, can you explain again?
I said we had two layers, layer A and layer B. B layer was directly touching the surface and A layer was above B layer. Okay, or you can say this A layer is touching the surface and B layer is above A layer. Okay,
Yes, sir.
the layer which is touching to the surface will be almost static because it will feel maximum repulsion, sorry, maximum friction. The
Yes.
layer above it, which is not directly touching the surface, it will have more velocity.
Yes, sir.
So there will be some velocity difference, right?
Yes, sir.
Now, more the area of the two layer. If you have more area, then more friction will be there. More area, then more friction will be there because they are in contact more. Less area, less friction will be there. So if the surface area is more, friction is more, so viscous force will be more,
Yes, sir.
right?
Yes, sir.
Okay. If the distance between the two layer, if you increase the distance between the two layer, it will go away from the static position. Flow, you can say. If you increase the distance between the two layer, it will go away from the static layer, and it will be able to move more.
Yes, sir.
For example, you have two hands. If you try to rub them, right? If you rub them, you won't be able to move them easily. But if you keep a distance between the two, then you can easily move them, right? If you rub your hands, then one hand will create friction for the other hand. You will not be able to move it, right? But
Yes,
if
sir.
you keep some space between the two, you can easily move them. That is what is happening here.
Okay, sir. Thank you,
If the
sir.
two layers are in contact, they won't be able to move. If the two layers are not in contact, then they won't be able to move. Understood?
So then how is it related to liquid?
We are talking about the layers of liquid only, na? This
Okay.
topic, what we are reading is liquid only. In liquid, there are so many layers. If you have any liquid, then it has so many layers of liquid. I have made only two. There will be several layers of liquid, like this. And all of them have some difference in velocity. The layer which is above among all of them have maximum velocity. This has minimum velocity. And the reason behind all of this is the frictional force or the viscous force.
Okay, sir. Got it. Thank you.
Understood, all of you? Sir, but a liquid will always flow even, though it is in contact with the flow, right? It assumes to be, or it appears to be moving in a particular way, right? You are saying that, but a liquid will always flow even. It appears to be even. It is not like that. We are talking of at the molecular level. Yes, हम molecular level के बारे में बात कर रहे हैं. Okay, if you take honey and water, then honey will not be able to move, but water can move. That is called viscous force. Yes. अगर आप हनी लेते हो, ग्लिसरीन लेते हो, तो यू विल बी एबल टू सी दैट दे आर थिकी लिक्विड्स. वो थिक होते हैं. क्यों थिक होते हैं? बिकॉज दे हैव मोर इंटरमोलिकुलर फोर्सेस ऑफ अट्रैक्शन, and that particular thing is resisting them to move for their flow, and that is called viscosity. Okay, Sanika, Sanjana. Sir, is it A? No, we are relating this with force, the viscous force. This is multiply. This is proportional. Sanjana. Now to remove this proportionality sign, we will put some constant. That is eta. eta. Okay. So it will become F is equals to eta into A into dV by dz. This is called coefficient of viscosity. Coefficient of viscosity. Viscosity. Or what will be the case with the topmost layer since it is pulled downward? Will it affect velocity? Topmost layer will have with respect to the others as it is maximum away from the static layer. ये देखो अगर हमारे पास ये एक लेयर है, दिस इज सेकंड लेयर, दिस इज थर्ड लेयर, दिस इज फोर्थ लेयर, दिस इज फिफ्थ लेयर, दिस इज सिक्स्थ लेयर. So let the velocity of this layer is 0.5 meter per second because it is directly in contact with the surface. ये surface के साथ directly contact में है तो इसकी minimum velocity होगी. ये surface है. Now this layer is in contact with the slowest layer, but it is not in direct contact with the surface. तो क्या हो जाएगा? It will be better. This layer is in contact with not with the layer which is direct contact with surface. This will be even farther away or far away from the surface. It will have more velocity. It will have more velocity. It will have more velocity. This will have more velocity. Fine. Okay, yes.
Sir, will the surface tension affect the topmost layer velocity?
Surface tension. We are talking about viscosity here. Surface tension is because of the intermolecular forces. This is also because of the intermolecular forces. So whatever the effect you are thinking about the surface tension, already they are happening here. यहाँ पर they have intermolecular forces between them, and because of intermolecular forces only, their velocity is decreasing. Okay. But layer is in the topmost, it is farther away from the surface, so it will have maximum velocity. And you can say gradual change in velocity. Gradual change or gradual decrease बोल सकते हैं. Gradual increase in velocity of the layers of liquid as we go from top to bottom, called laminar flow. Laminar flow. Laminar flow. Laminar flow. ठीक है, ये जो आप ग्रेजुअल चेंज देख रहे हो उसको लैमिनर फ्लो बोलते हैं. अंडरस्टूड. Let's talk about the coefficient of viscosity. So eta will be equals to force into dz divided by dv into A. Coefficient of viscosity की unit क्या आएगी? What would be the unit of coefficient of viscosity? Force is Newton, distance is meter, area is inverse, and velocity is meter per second का inverse. ये हो जाएगा -1 Newton meter square inverse second will be the unit. Any doubt to anyone in this? Force is Newton, dz is meter, dv is meter per second square. Sorry, yes, meter per second square. Area is meter square. इसको पूरा रख देंगे, we will get this. ठीक है, ये SI यूनिट हो गया. CGS में क्या हो जाएगा? These all are important things. CGS में डाइन सेंटीमीटर स्क्वायर इनवर्स सेकेंड. ये CGS में हो गया. Understood? All of you? Understood?
Sir,
Yes.
could you please zoom out?
Done?
No, sir, 1 minute.
SI unit of coefficient of viscosity, coefficient of viscosity, coefficient of viscosity is Newton meter square inverse second. We can say Pascal second. We can say Pascal second. Pascal second. Done. If we take CGS unit, it will be dyne centimeter square inverse second. It is called poise. It is called poise. ये सारी information important है. Can be asked. Understood? All of you. You have done? The boy, you have done?
Done, sir.
Okay. So that is it for today. Happy Diwali to all.
So the chapter is
Next
over.
we'll do in the yes, chapter is also over. We will start new chapter after this Diwali. Great.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Please read this chapter again. If there is any doubt, please message me.
So just show the last line.
Excuse me, sir.